We're asked to show the gradient at several points on each surface to illustrate the meaning of a gradient, and also show the gradient on the level curves of the function. We will be showing the gradient on the surface using the 3D Calc Plotter JavaScript app from the Exploring Multivariable Calculus site. Let's first review the properties of the gradient. The direction of maximum increase of f is given by the gradient of f, and the maximum value of the directional derivative of f, or rate of increase, is equal to the magnitude of the gradient of f. And the direction of maximum decrease of f is given by the opposite of the gradient of f, and the maximum decrease of the directional derivative of f, or rate of decrease, is equal to the opposite of the magnitude of the gradient of f. And then finally, the gradient of f is orthogonal or perpendicular to the level curves of the function at the point x, y. Let's open up the app and show the gradient vectors along the surface. By default, this is always the surface that is shown, given by the function here on the left, and this is the first function we want to use to show the gradient vectors. However, to emphasize that 7xy is in the numerator, let's place the 7xy in parentheses. If we press graph, the surface does not change because the function is equivalent. Next, let's make the surface transparent by clicking the magnifying glass here at the top. Now we click this button here, which is the Show Hide 2D Trace Plane. Then click the arrow to the right, and now we select Show Gradient at a point. Once we do this, we click on a point on the 2D trace plane here. Let's click on the point 1, 1, or roughly 1, 1. And the gradient vector is shown here in the trace plane, as well as on the surface. Before we animate the gradient though, let's orient the xy of our three-dimensional graph in the same way the 2D trace plane is oriented. So let's have the positive x-axis toward the right and the positive y-axis going backward or upward. Now if we look at this blue point, this red vector is pointing the direction of maximum increase, or the steepest ascent, from this blue point. So if we look down on the xy plane of the surface, again, if you can think of being at this location on the surface, if you were to walk in the direction of the gradient vector, this red vector, you'd be walking in the direction of the steepest ascent, which is a direction in which the function increases the most. And the magnitude of this vector is equal to the maximum value of the directional derivative in this direction. And the vector in the opposite direction would be the direction of steepest descent, or the direction in which the function decreases the most. Let's go ahead and animate this point across the surface and view the gradient vectors. Again, the red vector is pointing in the direction of maximum increase, or steepest ascent. And now let's show the gradient on the level curves. To do this, we click on this button here, which is Draw a Contour Plot. Let's go ahead and leave the settings as they are, but let's change the color to purple. And now click Create Plot. And now if we close this, we can see the contour plots in the XY plane shown here. If we click on the plot here on the right, we can also see the surface as well as the level curves at the same time. And what we'll notice is that the gradient vector is perpendicular to the level curves, which we can see on the 2D trace plane on the left, as well as on the surface on the right. Again, anywhere that gradient vector is, it will be perpendicular to the corresponding level curve at the blue point. And of course, it still points in the direction of maximum increase, or steepest ascent, of the function. Let's graph our second surface, which is given by f of x, y equals x squared minus y squared. Let's reset the entire plot by clicking the double arrows here in the upper left-hand corner, which will graph the initial function, but now we'll clear this function and enter z equals x to the second minus y to the second. Press enter, or we can also press graph. Let's make the surface transparent by clicking the magnifying glass. Then we'll select the 2D trace plane button here then the arrow to the right, and then show gradient at a point. Then click a point in the 2D trace plane. And again, let's orient the XY plane in the three-dimensional graph in the same way as the orientation of the 2D trace plane shown here. So we'll rotate this so the positive x-axis is toward the right, and the positive y-axis is moving upward. And now let's animate this blue point across the surface and view the gradient. Again, the red vector is a gradient vector pointing in the direction of maximum increase of the function or the steepest descent. So if we stop here for a moment, this may not look like the direction of maximum increase or steepest descent, but if we rotate the surface, we can see in this direction we would be moving toward the highest point on the surface, which is in this direction here. Let's also show this on the level curves. To do this, we click this button here, which is the contour plot button. Let's change the color to purple again and click Create Plot. Let's close this window. Notice how we have the contour plot on the left and right. If we click on the graph on the right, though, it'll also show the contour plot on the surface. And what we'll notice is that the gradient is perpendicular to the level curve passing through the blue point. I hope you found this helpful.